I'm presenting the solution to homework 15, problem 1. We have this overhung truss with these forces of FF and FE of 600 and 400. I think actually I got them backwards. Yeah, this is 400, not 600. Doesn't matter. And they're all based on 2 meters right here. Determine the forces in each member using the method of joints. Label each of the members as label whether each member is in tension, compression, or zero force member. Okay, so I thought I mixed up the words, but I just said them wrong. So I pre-wrote it out here. Let me move this over, and I don't know if that light is too bright. Yeah, that's okay. That's fine. All right, so what I want to do most of the time for these is to do an FBD of the whole thing. So I will draw it out as a kind of a piece, like right here. And let me see, did I make it so that it looked like those things are underneath each other? They should be underneath each other. Yeah, that should be underneath, but I don't think my sketch looks that way. They look like they're kind of away from me. Let me fix it. They should be above each other right here, right? Okay. My sketch is bad. So I have a force right here and a force right here. And from the values that were given, FE is that one, so that's 600 newtons. And this is 400 newtons. And we're going to have a reactions right here, and that's going to be FAY. I guess I usually use R. I usually go R's for reactions right here. So the RAY and RAX, and then right here I'll also draw these as positive. I actually could kind of guess which direction they're going to go, but I won't. I didn't label that one. What is that one? Is he B? He was G. Okay. G. So RGY, RGX. Okay, and some values here. This is going to be 6 meters in between there. This is going to be 2 in between here. 4. What did I just say? Why did I say 6? It's going to be 4. And then another 2 right here, not that it matters. Okay, so this is our FBD of the whole thing. Here's X and Y. We got it all down. I'm going to do the sum of the moments. Let's do it about A first. So the sum of the moments about A are going to be equal to... That'll allow us to get this guy right there. And so, is that true? Sorry, I'm just thinking about something here. Taking a look at the support on this thing. Is this thing over... Is this over constrained? I think this is over constrained. Oh my. No, I think it's just enough. Let me mess around with it as I'm going through. I don't know. It just struck me that all I'm going to be able to find from this is this value right in there, which is going to allow me to find this value because you could just look in the X direction here. So let's just go ahead and do that, right? So I'm going to say everything's in negative, by the way. So we have a negative 400. Everything I meant is clockwise, so it's going to be negative. It'll be times 2, and then it's minus 600 times 6. And then this one right here is also in the wrong direction, so RGX, and that's going to be times 4 equals 0 right here, right? So when we go 400 times 2 and 600 times 6 and add them together, and then divide by 4, we get that RGX is a negative 1,100 newtons, which means that it is actually pointing that way right there. So that's actually going that way, which kind of makes sense. Then I do the sum of the forces in the how am I going to do this? Okay, some of the forces in the x direction. And what we could say is we have a negative 1,100 plus RAX, excuse me. It's going to be equal to 0, so RAX is equal to 1,100 newtons going that way. All right, so sure. We were always golden here. My problem is I don't necessarily know. Okay, I see. This one can't support. I should never have drawn that in there. I was going too quickly. You'll notice that that's pinned right here, right? That this right here, and that's pinned right there. So this, I made a mistake. This one can only go in that direction. So now we could go to sum of the forces in the y direction. We could have always done that. But the sum of the forces in the y direction are equal to 0. Yeah, that was a little nerve-wracking right there. I guess I just had a nerve-wracking kind of time lately. So we can find that RAY, we do that in our heads, is 1,000 newtons, and it is going up. All right, so now we go to the individual things, method of sections. And we could start just about anywhere here, but some of the easiest one is probably right there at A. So I go FBD at A. Maybe I'll make this thing down a little bit lower. There we go. And we have this, and then in terms of forces that are being added onto this thing, we have this guy, and then we just showed that it's going to be him right there, right? So this is going to be my FAB, and this is going to be my AF. And this guy was RRAY, which was 1,000. And this was RAX, which is equal to 1,100. The angle that's going to be right in there, we could do by the angle, but you could see it's going to be that angle right there is going to be, and maybe I'll call it there theta A is the inverse tangent of 2A over A, so just the inverse tangent of 2, which is 63.43 degrees. Okay, so the sum of the forces in the y direction, actually you could just look from observation in the y direction here, that has to be coming down. This one, we don't actually know which way that it's going to go. We have this going to the right and this going to the left, so this is really going to be determined by what this is right here. So we'll start out in the y direction, and we say that we have 1,000 minus FAB times the sine of 63.43, and we get FAB equal to so 1,000. Then it's going to be 1,118 newtons, right? And we note that it's going to be in compression. So we do the sum of the forces in the x direction equals 0, horizontal to the right being positive, and we go 1,100 right there. And I'll assume this one is plus right here, but then it's going to be minus 1,118 times the cosine of 63.43 right there. And then I'll call it plus for right now. FAF equals 0. But I think we can kind of see that it's we're going to find that it too needs to go push in that direction right there, because we can see that when we take 63.43 and take the cosine of it and multiply, we get like 501 right here, right? So we're going to have that FAF is equal to a negative and 1,100 right here. I guess I'm just going to write 600 because I think my thing is off right here. So it actually is coming in that direction right there, right? That's what we learned from this. So FAF is equal to 600 newtons compression. So they're both in compression. Right there. So the next joint to go to, right? So so this is compression. This is compression. Let's come up to this guy right here. Let's come up to B. So FBD at B. And we already established this is going to be pulling in that direction. So this is, actually we could probably do at G right here. We could establish just from observation that the FBG is equal to our 1,100 in tension. That's just from the reaction right there. So we have this value that I'll call BG because we're looking at B right now. We also have a force coming this way, force coming that way, and a force coming this way. So looking at this right here, we had this in compression, 1,118. So it's going to be coming up here, right? This is the F. FAB. Okay, so if that's coming up, this must be coming down, because this one right across over there, that's going to be BF. And then this one we don't actually know, because this one's going to the right and this one's going to the left, so which is going to win? I think this one has to go to the right as well. That's my guess. So some of the forces in the Y is what we start out with here. And we'll go FBAB right here. That's 1,118, right? And even though okay, so the angle right up here is the same one that we found over before. So that's going to be, we're doing the Y of the thing. So I think it's going to be the sine of our 63 point what have you. 63.43. Right, that's the same angle as right here. So there you go, 63.43. We're probably going to get something sort of a similar configuration to the other guy. So we're going to go minus FBF. Is that it? Yep. So FBF, it's going to be 1118 times 63.43 sine times, yes, so that's nearly 1,000. And I think it would be exactly 1,000 if we, yeah, I think so. Sure. Yeah, it would be 1,000. It's just the decimal places, the rounding errors. Newton, and it's pulling on a thing, so it's in tension. And then we could say in the x direction, we have this value right here, negative 1,100. And then here we have positive 1,118. I just want to double check on my value. Yeah, okay. And now it's going to be the cosine of 63.43. And then my plus FBC. Is that right? So I said 1,100 and 1,118, 63.43 cosine times, and then we're subtracting out. So FBC is it's very close to that 600. 599.9. Probably just a rounding error. And let's see, which way do we draw it right here? That must be in tension. Let's see, who else? Let's see, I guess we can go to, let's go to F. So we're going to go to him next and say FBD at F. Okay, so this guy we just got, right? This one right here was previously AF, which we see was in compression. And then this one we just got. Did we get that one? No, we haven't got that one yet. But we could see that he better be downwards because there's nothing else to take care of the y direction here. So that's going to be FCF. Right, that's the one that's coming up right into there. And that's 45 degrees because, right, it's 2A and by 2A. And then this last one right here, we actually don't quite know him. He's FEF. Let's start out with the y direction first. So we have FBF, which we just found was 1,000. Oh, we also have to apply, whoops, that's an important thing right there. We need to plug our 400 newtons in. Right, there's a load. There's a load right there. Okay, but we're still okay with the things that we need to have. Right, so there's that, and minus the 400, and then we're going to have a minus FCF, and we're going to call that 45 degree right there. So we'll say that's the sine of 45. Although it doesn't matter whether we use the sine or the cosine. So CF right there is, and by the way, I'm not even sure that it's going downwards now, but I think, yeah, it's still going to go downwards. So just have like a net of 600 right there, and then divide it by the sine of 45. So we get 848.5 newtons, and that's in compression. And then the next, oh yeah, we need to do the sum of the force in the x direction. I'm going to assume this is positive for the time being. So we said FAF, which was this guy right here, 600 in compression. So we say 600 and minus 848.5 times the cosine of 45, right? So that's not a lot. So 45 cosine times is 600. What's interesting, right? That's 600 minus 600. We actually end up seeing that FEF apparently, and I'm double checking here, I think he's going to be a zero force member. Unexpected. All right, so but we could actually probably, I think I'm looking at this other thing, we could actually have figured that out here. But let's check them out and keep going so we can double check. We can go to C now. We can go to C. We have FED at C. And so we have a line there, a line here, and a line there. Now, maybe I wanted to go ahead and go to D. And look at what would we do if we went to D? There'd be no forces on this. So that's a zero force member, and that's a zero force member. So this right here is a zero force member. Or there. That's a zero force member. But anyway, we have this guy right here. We just got him, right? He was the diagonal. He's the FCF. And he was in compression. This was FBCCB. BC? Where'd you go? Yep, he was in tension. And then this guy is a zero force member. So FCD, zero force member. So this guy right here, he must be coming down, right? FCE. So you do the sum of the forces in the y direction, x direction. Now we already know this. So it's really in the y direction. So we have this coming up positive, and that's the CF. So 848.5. And times the let's say the angle is right there. So if we're going to do it the right way, we'd say the sine of 45. Not that it matters. And then this was negative FCE. Now it better come out to be 600, right? And it looks like it's going to be in tension. Now, like, you could have found that out earlier by just coming to, like, right here at E, right? And you could see that, I'll write it out, FBD at E, right? This is my 600 newtons. And this is my FCE. This is from observation. FCE is equal to 600 newtons. And then even in a horizontal direction right here, you could see, there's nothing that can happen here. So ED is a zero force member. guess that's the way I was writing it before. And also from here, we just noticed before that EF, right in here, he was also a zero force member because he had to be a zero force member, right? They're going across each other. So, answers. There's a lot of them, unfortunately. Let's go alphabetically. FAB. FAB, where did you go, FAB? You're like near the very beginning, aren't you? Yeah, there you go. 1,118 newtons compression. All right, so how about FBC? FBC, where'd you go, FBC? 600 newtons. Is in tension. All right, so we go BF, FBF, where's FBF? Is 1,000 newtons in tension. And then BG. All right, so that was one that we just got from observation as 1,100 newtons in tension. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 of these right here. So let's go down here in a row. I think I'm going to go FCD is zero force member. All right, that's that one. And then continuing in alphabetically, FCE was 600 newtons. And then let's see who comes next. FCF. That's the diagonal right there. And I think we found he was 48.5 newtons in compression. Who's next? CF, CE, CD, C. Okay, so let's go to D. DE, FDE, zero force member. All right, and so D. So let's go EF. Was also a zero force member. That was the one in between there. And I think the last one was I should have done on AF. I forgot. AF. And that was an early one, wasn't it? Yeah, that was 600 newtons compression. Right, there you go. So there is problem 1. Yeah, these are a lot of times. There's a lot of things to write down here, but it's these are good exercises to go through. Not just because in wanting to know all the forces in a truss are important, but there's a lot of like FBD logic as part of this. So it's a worthwhile pursuit. So on to the next one.